Okay, family, we're getting there. We're on our third part of this lesson. So we have looked at two-way tables. What information do they give us? Then we looked at marginal distributions. The inside values do not matter. It is the outside in quotation marks, but the edge values that matter. And all of our percentages are based off of the table total. Now, some of those things are going to change once we start doing conditional distributions. So marginal distributions do give us some information that is helpful, but marginal distributions tell us nothing about the relationship between two variables. When we first started this lesson in the first video, I was telling you guys that I really like two-way tables because I find the information to be interesting, and that we do a two-way table usually because we think that there is a relationship between the two variables we're looking at. So if the reason that we use a two-way table is to investigate if there's a relationship, then we need something besides a marginal distribution to help us with that, because marginal distributions tell us nothing about the relationship. And you can kind of see that when I cover up the table for the different distributions. Of course, a marginal distribution isn't going to tell me anything about a relationship because I only care about the gender data when I'm doing a marginal distribution for gender. I don't care at all about the type of car data. And it's similar the other way. Of course, this doesn't tell me about the relationship between gender and type of car, because when I find a marginal distribution, I don't care in this case about the gender at all. I just care about how many people drove a car, a sports car, and how many people drove an SUV. So marginal distributions aren't enough. We need to now look at how we compute conditional distributions. So to describe a relationship between two categorical variables, we must calculate the conditional percentages. So I'm going to highlight that. And there's a lot of information on this page, so I'm hoping the way that it is organized helps you guys keep track of what's happening. Okay, so the first thing that I want to highlight is now we care about the inside values, and we don't care about the overall total. Look, I've covered up the totals columns or the total column on this table because I am not going to base any of my percents off of the total. So we are not using the total amount anymore, and we are very interested in the values inside the table. So just like the marginal distribution, we've actually already calculated some conditional percents. So that was on the first page. 1B said, what proportion of branches from an urban location are profitable? This is a conditional percent. They want to know how many branches are profitable on the condition that they're from an urban location. So the condition is it has to be an urban location, and then we want to know how many are profitable. Same on part C. Our condition is that it's a rural location. So a conditional distribution is based off of the category total and not the table total. So when we find the marginal distribution for SUVs, we only care about the total number of SUVs. We don't care about the table total. And when we find the marginal distribution, no teacher, not marginable I am on a winning streak right now. When we look at the conditional distribution for sports car, we do not care about the table total. We only care about the total amount of sports cars. And while I'm covering up this information, I want you to see that the shading of the boxes now go in the direction that you should go. So here for an SUV, you're working your way down, and here for the sports car, you're working your way down. The sports cars are only based out of 84, and you don't even need the SUV data. If you want to know the conditional distribution for the sports cars, all you need is information about sports cars. Same for the SUVs. All you need is the information about the SUVs. So let's go in and look at the different kinds of conditional distributions we can find. So this top one, or the one that I have highlighted here, I should say, is the conditional distribution for gender. This is the conditional distribution for gender. So if I am asked to find the conditional distribution for gender, they want me to do both genders. They want me to do family. Listen, please do not murder me. This is not the conditional distribution for gender. What is your teacher thinking? So I realized I was saying the wrong thing because I was looking at the words here, SUV and sports car. This variable needs to match. So if I'm talking about the type of car here, that means that this distribution is for the type of car. If it asks you to find the distribution for the variable, then you go through and find it for both of the categories. So if it says find the conditional distribution for type of car, that means you have to find it for SUV and you have to find it for sports car. You have to find the conditional distribution for each category. Now we can get a little bit more specific. The conditional distribution for type of car is made up of the conditional distribution for SUVs and the conditional distribution for sports cars. Okay, so let's start by finding the conditional distribution of the SUVs. So this wants to know, of all of the people who bought an SUV, what percent of them were male? So we take the number that were male over the total number of people that drive an SUV, and we convert that to a percent. So I am getting 13%. And then remember, we're working down. Notice that the arrows are going down, so we work down. Next one, we want to know how many of the people that drive an SUV are female. So we do 135 divided by 156, and we get 87%. So of the people that drive an SUV, 87% of them are female and 13% of them are male. That's not surprising given that we think that gender might influence the type of car you drive. It makes sense to me that most of the people that drive an SUV are female. These boxes right here are describing what you found. So I just put it in words for you, what I just described. Of all the people who drive an SUV, 13% are male. Of all of the people who drive an SUV, 87% are or were female. Okay, now on this one, find the conditional distribution for sports cars. So what we want to know is, of all of the sports cars driven, what percent of them were driven by males and what percent of them were driven by females? So I want to do 39 divided by 84 for the males. Out of the 84 sports cars drivers, 39 of them were male. That is 46%. 45 out of 84 were female. That is 54%. And then these description boxes are the same idea. Of all the people who drove a sports car, 46% were male, 54% were female. Biggest takeaways so far. Your arrows for your distribution are pointing down. That means that you work down. You work one column at a time. The percentages are based off of the column total. So both of these are out of 156. Both of these are out of 84. We do not care about the table total. So this is our conditional distribution for type of car. That's not the only conditional distribution we can find. We can find the conditional distribution for the other variable, which is gender. So now we're on gender. I think I'm going to try to write that a little bit smaller. Sorry about that. I'm going to box that just like I did before. So conditional distribution for gender is made out of two things. It is made of the conditional distribution for males and the conditional distribution for females. Notice that your arrows are pointing to the left. Your shading matches that. It is moving to the left. If we're going to find the conditional distribution for males, all we care about is the male row. We do 21 divided by 60. That's saying to me, of all of the men, what percent drove an SUV? So 21 out of 60 drove an SUV. That is 35%. Of all of the men, what percent drove a sports car? Well, 39 out of 60 drove a sports car. So that is 65%. So of all the males, 35% drove an SUV, 65% drove a sports car, and then this supports what we thought from the beginning. More men drive a sports car. Or men, I should say, men are more likely to drive a sports car. Now we do something similar to the female row, except for this time all of our proportions are based off of 180, the total number of females. So of all the females, 135 of them drove an SUV. That is 75%. And of all of the females, 45 drove a sports car. That is 25%. Once again, this information supports our thoughts from the beginning. Females are more likely to drive an SUV. I'm going to fill in this information now. So this box here is telling us 35% of males drive an SUV. This is telling us 65% of males drive a sports car. Down here, we got 75% of females drive an SUV. And 25% of females drive a sports car. I'm going to do a little highlighting here of some very important information. So if we're looking at the males, what this information is telling us is that men are more likely to drive a sports car. Men are more likely to drive a sports car. 65% of the men drove a sports car. Similarly, down here, what this is telling us is that women are more likely, or I should say females, to drive an SUV. So men, just kidding, males are more likely to drive a sports car. Females are more likely to drive an SUV. So that is the basics of a conditional distribution. I am giving you one bonus problem. You're probably going to need to do it on a separate sheet of paper. I did mine on an index card so I could keep it, and I'm going to tape it into this problem when we're done. Now remember, you're not forced to do these bonus problems because I'm not going to come through and check them, but you might want to do it just to verify that you understand what a conditional distribution is. So the bonus problem is find the conditional distribution for housing status on number 2 from the previous page. So previous page looked like this. Uh-oh, it's really number 1. Find the conditional distribution for housing status. It's number 1. So we found the marginal distribution for housing status. Now I want you to find the conditional distribution for housing status. I want you to pause the video and then I want you to check. Mine is already done, so I'm just going to flip this card over and show you. I am really hoping, though, that you will take advantage of this opportunity and actually verify that you understand. So I'm going to flip now. Pause if you are going to do it. Okay, so I had to make my own table because that table was too small. I couldn't fit everything in that I needed to fit in. One thing that I want you to notice is that I have taken my housing status variable, which is on this left-hand side. And because it's on this left-hand side, that means I move across. I have to move across the table. It's probably hard for you to see because my highlighting colors are so similar. Maybe if I got a different background color. But I have highlighted them in the different colors. Also notice moving across, the totals that I'm using are the same. 254 people owned, 94 people rented. That's why I'm basing my percentages off of those values. 68% of married people own, 32% of not married people own, 43% of married people rent, 57% of not married people rent. This supports what I was thinking about this relationship. Married people are more likely to own. That's what I have circled here. Married people are more likely to own. Not married people are more likely to rent. So this is different from a marginal distribution in that we no longer care about the outside values. We care about the inside values. We don't use the table total anymore. We use the actual category totals. And the reason why this is so important in statistics is because conditional distributions tell us about the relationship between two variables. If we are looking at two categorical variables, it is because we think there is a relationship. And these are the numbers and the calculations that help us describe that relationship. Okay, so that is it for conditional distributions. We have already learned a ton. We have the basics of our two-way table. We have our marginal distribution. We have our conditional distribution. And I really am gonna tape this card in because I want to keep it, especially if I'm gonna use it to study or something. And then next up, we have what this has all been building to, and that is being able to conclude or determine whether two variables are independent or if they have an association. So all three of those lessons are building up to this final idea. Okay, maybe take a break, get a snack, maybe watch a lot of TV, and I'll see you in the next one. Love you guys.